Well, no lecture on distributions in statistics would be complete without talking about the granddaddy of them all. The normal distributions are used very commonly in statistics, as you know from your studies in parametric statistics, primarily because of the mathematical properties associated with these distributions that give way to the central limit theorem. That is, that the sampling distribution of a number of statistics, including the mean, is asymptotically going to be a normal distribution. Here's that very familiar bell-shaped curve that we see with a normal distribution. This particular distribution I'm showing you here is one in which there's a mean of 50 and a standard deviation of 10. The properties of the normal distribution. The normal distribution is used as a standard for comparison, even in nonparametric statistics. When we talk about distributions of whether they're, for instance, platykurtic or leptokurtic, what we're talking about is how the bulk of the distribution, the mode of the distribution, how that compares to the normal distribution. We state that distributions are leptokurtic if in fact there's an even higher amount of our area in the center of the distribution than we would expect to find in a similar range in the normal distribution. Also, when we talk about tails being heavy or light-tailed, what do we mean by that? We use the normal as the standard, and heavy-tailed would be that we have more units than we would expect in the normal distribution out in the tails of our distribution, and light-tailed would mean that we have less units than we expect in the normal. In the uniform distribution, for example, where we don't have any units out in the tail, we say that that's light-tailed. The parameters of the normal distributions are mu and sigma, the mean and standard deviation. If you know the mean and standard deviation, and you have the mathematical function for a normal distribution, you can create one precise normal distribution, like I did for you in showing you a picture where I had set the mean to 50 and the standard deviation to 10. The standard normal is a name that we give to a particular normal distribution that's a reference distribution, has a mean of 0 and a standard deviation of 1. And when you look up tables of cumulative probabilities for the normal distribution and associated z-scores, those are all based upon this standard normal reference distribution, which is simply one normal distribution where we have a mean of 0 and a standard deviation of 1. You probably are aware that approximately 2/3 of the distribution is within one standard deviation of the mean, so therefore the bulk of the distribution falls close to the mean, within one standard deviation. You may also know that only 5% of the distribution is beyond 2 standard deviations of the mean. And in fact, if we took it a step further to 3 standard deviations, that includes almost everyone. 99.7% of the distribution is within 3 standard deviations of the mean. So we seldom need to go beyond 3 standard deviations in terms of looking at units in our distribution of data. Even though the normal distribution, unlike the uniform, has an infinite range, from a practical standpoint, our range is 3 standard deviation units on either side of the mean. So that's the normal distribution, used as a standard for comparison, and it's one of the distributions we'll consider whenever we look at data to see if it appears as though our data might fit a normal distribution.